Hello YouTube, coming up on this how-to installment of All Things Life. How do we take this rig and 6 of these cameras and end up with an immersive 360-degree video? Stay tuned. Ryan Erickson here for All Things Life, where we explore and review household ordinary to tech extraordinary. Be sure to subscribe to the All Things Life channel. You never know where we'll go next. Today, let's talk about building a 360-degree video setup using the Gitup Git2 camera and RoboGoods camera rig. There are a wide array of rigs available for 360-degree video work. Before we begin, let's dig in and take a look at some of the concepts and terminology involved in 360-degree video. First off, stitching. Stitching is the process of taking multiple still or video images and blending them together into a single image or video projection. A projection is really how the output generated by stitching is presented to the end consumer. One of the most common projections in use for 360-degree video posted to YouTube, for instance, is what's called equirectangular. Now, equirectangular is where the image is flattened and projected, if you will, onto a rectangle. When viewed in a two-dimensional plane, an equirectangular image appears stretched, especially near the top and the bottom, but when viewed in a 360-degree enabled player, the image will wrap around the user and looks much more natural without nearly as much stretching visible to the eye. Other examples of projection include Little Earth. Little Earth is where the video is projected wrapped around a sphere. It gives some very unique perspectives to the 360-degree video. Stitch orientation is another concept that's important when discussing 360-degree video. Generally, cameras will be mounted either such that overlapping regions of the frame, the seams, are arranged either vertically or diagonally when placed in a 360-degree rig. The zenith and the nadir. The zenith and the nadir are the regions at the top and the bottom of the stitched frame. Some camera rigs don't include enough coverage and don't have a wide enough field of vision or enough cameras to cover the region down at the bottom of the frame. This is the nadir. Likewise, if there's not enough coverage near the top of the rig, the zenith will have a black spot. If either of these don't have decent coverage, you'll end up with a black hole at both locations when you go to stitch. Frame sync is also important. In order to achieve a proper stitch, all cameras must be synchronized so that they all start on or as close to the same time frame as possible. This sounds complicated, but most stitching tools now allow the use of audio to sync the cameras. So by giving a single loud clap once all cameras are rolling, you can later achieve frame synchronization in post-production. So, with definitions out of the way, let's talk specifics. The particular rig we are building utilizes 6 Gitup Git2 cameras, arranged in a rig that provides full 360-degree by 180-degree coverage, meaning there will be no zenith or nadir blind spots, and the user will see a fully immersive image when viewed in a 360-degree enabled player. Let's put this thing together. I'm going to start by ensuring that all Git2 cameras are configured using the same settings. It's critical when you're doing 360-degree work that all of the cameras capture at the same resolution, the same frame rate, and are configured such that they have very similar white balance and metering modes. I have found that 1440p with a 4:3 video frame setting is optimal for the Gitup Git2. Make sure that image stabilization is turned off. Although somewhat counterintuitive, image stabilization operates by cropping a portion of the outside of the frame, which will have a negative impact on stitching performance since you're throwing away some pixel data along those seams at the overlap region of each camera. Once all cameras are configured the same, let's mount them into the rig. For each camera, I have routed a mini USB cable through the screw mount and down through the base, allowing me to hook up external battery packs as well as allowing for quick and easy access to download the videos from the cameras once I'm done shooting. Okay, with our final rig built, it's time to run a test. The last step is to find something to mount the rig to. In order to achieve the most transparent and immersive experience for the audience, keeping bulk to a minimum below and around the rig is important. So don't reach for that video tripod with the bulky fluid head. The tripod head will just end up getting in the shot. Instead, reach for a light stand or a tripod that allows for a standard 1/4 inch or 3/8 inch connection and doesn't include a large amount of bulk below the unit itself. I use a Manfrotto 5001B. This thing is stable and allows me to keep a very minimal footprint. And now, the moment of truth. Press the record button on all of your cameras, and once you have confirmation that all cameras are recording, give a solid clap to allow for frame synchronization in post-production. As you record, keep in mind that anything extremely close to the camera will experience a parallax effect as multiple cameras will see that image, And you won't get a very high quality stitch with everything really close. Keep your subjects around 3-foot distance if filming a principal, or place the rig near the center of the action for capturing events. Thanks for joining me for this guide on building a 360-degree video setup using the Gitup Git2 and RoboGoods camera rig. I have included links to all the equipment used for this rig in the video description below. Be sure to subscribe to the All Things Life channel and leave your thoughts in the comments section below.